Bismillahirrahmanirrahim. Dear students, have a nice day. Hope you will be fine and best of your health. This is Dr. Sajid Mahmood Rao, Division of Science and Technology, University of Education, Lahore. Today we are talking about the second part of isolation, purification and structure elucidation of the natural products on the basis of phytochemical investigations on the constituents of Salvia centronifolia and Indigofera hyacintha. Let's see the proton NMR spectral data of Salvin A. Here we will discuss the proton behavior, proton splitting pattern, chemical shift values. We will also observe how different functional moieties are confirmed on different carbon atoms within the basic skeleton of these molecules. Salvin A is isolated as a colorless amorphous solid through column chromatography and flash chromatography techniques, which shows the positive color reactions of a triterpenes and a brisk effervescence with the dilute solutions of sodium bicarbonate, which reveals the presence of a free carboxyl group. The IR spectrum showed the absorptions due to hydroxyl group, that is at 3444, acid carbonyl group 1700 and double bond at 1650. The HREIMS showed major ion peak at 488 corresponding to molecule formula C-30H48O5, which calculates its molecular mass as 488. The proton NMR spectrum showed tri-substitute double bond at sigma 5.25, that is triplet, and J value 3.4 Hz, and two oxymethine protons at 3.61, one proton doublet of doublet of doublet, and J value is 10.8, 9.5 and 4.0 Hz, and 2.9 to 1 proton doublet, J value 9.5 Hz. In addition, 5 tertiary methyls were observed as singlets at sigma value 1.31, 1.16, 1.03, 0.99 and 0.78, while doublets of 2 further secondary methyls were observed at sigma value 1.00, 3 protons, that is doublet, and J value is 5.8 Hz, and 0.91, 3 protons, doublet, and J value is 6.7 Hz. The above data was consistent with an ursine type triterpenes carrying a double bond at carbon 12 position. Let's see the retro Diles-Alder fragmentation of Salvin A. Retro Diles-Alder fragmentations of Salvin A is the opposite of Diles-Alder fragmentation, in which the basic skeleton of the molecule is break down into different fractions by choosing pi bonds. So this was further confirmed by formations of characteristic retro Diles-Alder fragments at m/z 248, that is calculated for C16H24O2, and 240, that is calculated for C14H24O3 respectively. This confirmed the presence of 2 oxygen functionalities in ring DE and the remaining 3 oxygen functionalities in ring AB. The fragment at m/z 248 being common to that of arsolic acid allowed us to assign the carboxylic group at the angular of carbon 17 position. This was further authenticated by a peak at m/z, that is 203, due to the loss of carboxylic group from the fragment ion at m/z 248. The C-13-NMR spectral data of Salvin A is also used to confirm the structure of this molecule. It was also confirmed by the broadband and depth of C-13-NMR spectra, which disclosed 30 carbon signals including 7-methyl, 8-methylene, 7-methine and 8 quaternary carbons. The downfill signals at sigma 181.0 could be assigned to the acid carbonyl, while the signals of olefinic carbon double bonds were observed at sigma 138.2 and 128.5 respectively. 2 oxymethine carbons were observed at sigma 83.4 and 68.4, while a downfield quaternary carbons at sigma 72.9 indicated the presence of tertiary hydroxyl group. Let's see important HMQC correlations and HMBC correlations of Salvin A. HMQC correlations gives informations about proton-proton correlations, while HMBC correlations gives informations about proton-carbon correlations. Now we discuss first the HMBC correlations, in which the oxymethine proton at sigma 2.92 showed proton-proton correlations to the oxymethine protons at sigma 3.61, while the latter also showed the further proton-proton correlations with two other protons. This allowed us to assign the hydroxyl groups to carbon 2 and carbon 3 positions. The large coupling constants of the respective oxymethine protons allowed us to assign the equatorial configurations to both the hydroxyl groups. The remaining problem was to assign the position of tertiary hydroxyl group. The upfield shift of proton 3, that is doublet, and 2.92 indicates the position presence of hydroxyl group at carbon 5, which could further confirmed by the HMBC correlations. The HMBC correlations stands for heteronuclear multiple bond correlation. That is, an experiment gives correlations between carbons and protons that are separated by 2, 3 and sometimes in conjugated systems for 4 bonds. Thus, the absence of a cross peak does not confirm that carbon-proton pairs are many bonds apart. The important HMBC correlations indicates the oxymethine protons at doublet 2.92, which shows 2J correlation with carbon 4, which have proton value 14.1 and carbon 2 that have proton value 68.4, and 3J correlations with carbon 5 and that have proton value 72.9 and carbon 23 that have proton value 28.3 and carbon 24 that have proton value 16.4. The methyl protons at carbon 25 at doublet 1.16 showed 3J correlation with carbon 5 that have proton value 72.9, while methyl protons of both the methyl groups at carbon 23 and carbon 24 that have proton value 1.03 and 0.78 respectively showed 3J correlation with carbon 5 that have proton value 72.9. Recording of proton NMR spectrum of 1 in pyridine D5 did not induce downfield shift of methyl protons of methyl 24 and methyl 25. Therefore, alpha configurations could be inferred for the hydroxyl group at carbon 5. The stereochemistry at carbon 2 and carbon 3 position was finally confirmed through 2D NOESY, in which proton 2, that is 3.61, shows the correlation with methyl 24 that have proton value 0.78 and methyl 25 that have proton value 1.16 with methyl 26 that have 0.99 and proton 3 that have 2.92 with methyl 3 that have proton value 1.03. Thus, the structure of Salvin A is assigned as 2 alpha 3 beta 5 alpha trihydroxy or SANE 12 in 28 oic acid. You can see over here the physical parameters of Salvin B. Now we discuss the physical characteristics of this molecule. Salvin B is obtained as amorphous powder, which has amount to 20 milligrams. The specific rotation of this molecule is minus 53.80, that is taken in methanol, and the concentration of that solution is 0.013. The IR spectrum is taken in potassium bromide disc, and lambda max has values for carbonyl groups, carbon-carbon double bonds, as well as hydroxyl groups, which showed the presence of different moieties. The HREIMS, which shows the molecular ion peak at m/z 488.3495, that is calculated for C30H48O5, and the molecular mass is confirmed as 488. Let's see the proton NMR spectral data of Salvin B. The proton NMR shows two oxymethine protons at sigma 3.91, one proton multiplet, and at 3.74, one proton triplet. In addition, it shows signals of 6 tertiary methyls at 1.16, 1.08, 0.93, 0.92, 0.91, and 0.08, which consistent with an oleane type skeleton. The proton at 23 shows 3.64 and 3.36, one proton each AB doublet and J value 11.4 Hz. The proton at 18 shows 2.83 doublet of doublet and J value 14.01 and 4.1. The C-13-NMR spectral data of Salvin B shows 30 carbon signals comprising of 6 methyl, 10 methylene, 6 methine, and 8 quaternary carbons. Contrary to Salvin 1, it shows 2 oxymethine carbons at sigma 74.4 and at sigma value 66.9, and an oxymethylene carbon at 65.2. The signal of one of the methyl group at carbon 4 is missing in this molecule. The carbon values at 123.0 and 145.6 indicates the presence of tri-substituted double bond. So there is also a presence of signals at 180.8, which indicates the presence of carbonyl groups at carbon 17 position. Similarly, you can observe the signal value at 66.9 at carbon 6, which indicates the presence of hydroxyl group at carbon 6 positions, as well as the methoxy group is observed at carbon 4 positions, which is confirmed due to the presence of carbon signals at 49.0. So on this basis, the name of this molecule is 3-alpha-6-alpha-24 trihydroxyoleane 12-ene-28 oic acid. Let's see important HMQC correlations that is relevant to proton-proton correlations and HMBC correlations that is relevant to proton-carbon correlations of Salvin B molecules. Similarly, we will discuss here some important NOESY interactions in which we confirm the stereochemistry of hydroxyl group at carbon 3 positions and carbon 6 position. The oxymethine proton, which resonate at 3.74, shows proton-proton correlations with two other protons and hence could be assigned to the usual carbon 3 position. The smaller coupling allow us to assign an axial configuration to the hydroxyl group. The proton at 3.74 shows 3J correlations with carbon 5 and carbon 2, and the proton at 3.91 shows 3J correlations with carbon 8, carbon 10 and carbon 4, while the proton of methoxy group shows 3J correlations with carbon 3 and carbon 5. The other oxymethine proton at 3.91 showed proton-proton correlations with 3 other protons, limiting its position possible to either carbon 2 or carbon 6. The later position and the position of hydroxymethyl group at carbon 4 could be authenticated through HMBC correlations. The position of oxymethylene is deduced through C-13-NMR. In case of carbon 24 oxidation, the methyl 23 resonates at 23 to 25 ppm, while in case of oxidation of carbon 23, it is observed at sigma 14 to 16 ppm. In case of 2, the methyl group resonated at 23.0 in conformity to its presence at carbon 4 in a configurations. This was also supported by NOESY spectrum showing the interactions between proton 3 that have proton value 3.74 with methylene 24 that have proton value 3.64 and 3.36. Methylene 24 that have proton value 3.64 and 3.36 with methyl 25 that have value 0.91 and methyl 25 that have value 0.91 with methyl 26 that have value sigma 0.80, which is in accordance with the assigned structures of Salvin 2 as 3 alpha 6 alpha 24 trihydroxyolane 20 in 28 oic acid. Let's see the enzymatic activities of Salvin A1 and Salvin B2, which is confirmed and observed by using butyrylcholinesterase inhibitory enzymes. Cholinesterase is implicated as key biological players in the Alzheimer's diseases, which makes them logical targets for inhibitory therapeutics. According to the cholinergic hypothesis, the memory impairment in the patients with senile dementia of Alzheimer's type results from a deficiency in cholinergic function in the brain. The role of butyrylcholinesterase in normal aging and brain diseases is still elusive. It has been found that butyrylcholinesterase is found in significantly higher quantities in Alzheimer's plaques than that of normal age-related non-determined brains. Various concentrations of Salvin A and Salvin B were tested against enzyme butyrylcholinesterase, which displayed significant inhibitory activities against this enzyme. No inhibitory activity could be observed with the acetylcholinesterase enzyme. The IC50 values is given in the below table. In this protocol, glantamine is used as an active standard drug, which shows IC50 values against this enzyme is 8.7 plus minus 0.01 as compared to the compound 1, which shows IC50 values 12.5 plus minus 0.08, and compound 2 shows IC50 value against this enzyme that is 65.5 plus minus 0.01. Let's see the physical parameters of Santolinol 3. This molecule is isolated as colorless amorphous powder, which have a 20 mg. The presence of phenolic group is confirmed by the reaction of this molecule with ferric chloride, which shows the violet color, which indicate the presence of phenolic moieties within the ligand molecule. The specific rotation is calculated in methanol at concentration 0.042, that is minus 44.40. The UV spectrum is taken in methanol, which shows absorption at 277 and 217, which is typically presence of aromatic moieties within the ligand molecule. The IR spectrum is taken in potassium bromide disc, and it shows the absorption at 3480 and 1610 to 1515, which shows the presence of hydroxyl group and aromatic moieties respectively. The HR EIMS shows and confirms the molecular mass, that is 376.1512, which confirms the molecular formula, that is C20H24O7. So in the next slide we will discuss the proton NMR, C-13-NMR, HMBC, HMQC to confirm the structures of the Santolinol molecules. Let's see the proton NMR spectral data of the molecule Santolinol. First of all, we will discuss the presence of tetrahydrofuran moiety and their absorption signals. The signals at 4.71 doublet J value 7.3 Hz indicates the presence of proton at 7. Similarly, the absorption of methoxy group that is present at H9A, that is 3.83 1 proton doublet of doublet J value 11.1 and 8.2 Hz, and H9B, that is 3.73 1 proton doublet of doublet J value 11.1 and 5.70. Similarly, the presence of hydroxyl group at carbon 8 in the tetrahydrofuran moiety 2.30, that shows doublet of doublet and J value 8.2 and 7.30 and 5.7 Hz. The absorption at 2.97 and 2.89 doublet J value 13.9 Hz shows the presence of methylene at carbon 7. Now we will discuss the oxy moiety that is present within the tetrahydrofuran that shows the signals at 3.80 and 3.60 doublet, which confirm the presence of oxygen functionalities within the tetrahydrofuran moiety in the lignin molecule. Further, we discuss the methoxy group in the aromatic ring, which is confirmed. The protons at 6.74 doublet J value 8.1 shows the presence of hydroxyl group at carbon 4 position. Similarly, the hydroxyl group at carbon 3 position is confirmed due to the absorption signals at carbon 2 position, that is 7.12 doublet and J value 1.1 Hz. In the second aromatic substitution, the methoxyl 2 groups was confirmed due to the presence of absorptions at carbon 6 and 5 that is 6.80 doublet of doublet J value 8.5 and 1.1 Hz and 6.71 doublet J value 8.5 Hz, which confirm the two methoxyl groups at the second aromatic moieties. So in the next slide we will discuss the C-13-NMR spectral data. The C-13-NMR spectral data shows a striking resemblance of this molecule to the larisirazinol, that is lignin, which has been confirmed by the literature survey. In C-13-NMR, the broadband and depth resolve the total 20 carbon signals, which includes 4 oxygenated aromatic quaternary carbons, 2 aromatic quaternary carbons, 6 olefinic methine carbons, 6 tetrahydrofuran moiety carbons, and 2 methoxy carbons included. Now you can see over here in the tetrahydrofuran moiety there is upfield signals that shows 61.8 and 60.5, which indicates the presence of methoxy group at carbon 8 positions of the tetrahydrofuran moiety. Two signals resonate at 148.8 and 147.0 that indicates the presence of methoxy group upon the benzene molecules. So the other two signals that appears at 148.4 and 145.9 that indicates the presence of methoxyl group at the aromatic rings at carbon 4 and 3 moiety of the benzene molecules. Now we can see the signals for tetrahydrofuran moiety, that is 78.8, 85.6 and 82.48 that confirm the presence of tetrahydrofuran moiety with oxygen functionalities. Now at the end, the two aromatic benzene rings was confirmed, that is the presence of signals at 131.1, 111, 115 and 120. Similarly in the other sides 130, 123, 115 and 115 that confirm the presence of two aromatic moieties within the lignin molecules, which has been also confirmed by the literature survey. Let's see the no interactions of Santolinol. It has been observed by the literature the NOESY spectra is similar to that of larisirazinol, which also confirm the presence of tetrahydrofuran moiety as well as the structures of lignin molecules. So you can see over here the proton-proton correlations which confirm the presence of methoxy as well as hydroxyl groups at the benzene molecules. Proton 7 that has sigma values 4.71, which is correlated with proton 8 that have 2.30. Similarly, proton 8 prime have sigma value 2.30, which shows correlation with proton 7 prime and have value 2.97 and 2.89. The high resolution electron impact mass spectroscopy shows two fragments. One fragment shows at 151.0750, which confirm the presence of dimethoxybenzide moiety. The other fragment shows at 137.0230, which indicate the presence of dihydroxyphenyl moiety. The stereochemistry of the tetrahydrofuran moiety is confirmed by the inspection of treating model, which confirm and shows the configurations are at carbon 7, that is clockwise direction, and configurations S at carbon 8, that is anti-clockwise direction. Similarly, it has been proved that the configurations are at carbon 8 prime, which shows the presence of clockwise direction. So on the basis of these evidences, it has been confirmed the structures of this molecule is lignine. HMBC correlations of Santolinol 3. The proton NMR spectra is recorded at 500 MHz, while that of C-13-NMR spectral data is recorded at 125 MHz. Now we discuss the correlations of the proton to that of different carbon atoms within the lignine molecules. First of all, we discuss the carbon signals at different positions, which was appeared with broadband and depth of the carbon 13 spectral data. The signals at 11.4 shows at carbon 2 positions, 115.7 appears at 5 positions, 120.6 at carbon 6 position, 85.6 resonates at 7 position, 61.8 appears at 8 position, 60.5 shows at 9 position, 115.1 appears at 2 prime position, 115.6 resonate at 5 prime position, 123.7 is resonated at 6 prime positions, 40.5 shows the signals at 7 prime positions, and finally 77.8 signals show at 9 prime position. Now you can see over here the relations of the proton with that of the specific carbons. We will discuss here. The proton 2 shows the correlations with that of carbon 1, carbon 2, carbon 3, carbon 4 and carbon 7 position. Proton 5 shows the correlations carbon 1, carbon 3, carbon 4 and carbon 6. Proton 6 shows the correlations with carbon 1, carbon 2, carbon 4, carbon 5 and carbon 7. Proton 7 shows the correlations with that of carbon 1, carbon 2, carbon 6, carbon 8 prime and carbon 9 prime. Proton 8 shows the correlations with that of carbon 1, carbon 7, carbon 8 prime and carbon 9 prime. Proton 9 shows a correlation with carbon 7, carbon 8 and carbon 8 prime. Proton 2 prime shows correlation with carbon 1 prime, carbon 3 prime, carbon 4 prime and carbon 7 prime. Proton 5 prime shows a correlation with carbon 1 prime, carbon 3 prime, carbon 4 prime and carbon 6 prime. Proton 6 prime shows a correlation with that of carbon 1 prime, carbon 2 prime, carbon 4 prime, carbon 5 prime and carbon 7 prime. Proton 7 shows a correlation with carbon 1 prime, carbon 2 prime, carbon 6 prime, carbon 8 prime and carbon 8 prime. And finally, proton 9 prime shows a correlations with that of carbon 7 prime, carbon 8 prime, carbon 7 and carbon 8. This is the general correlations of the protons to that of the carbons, which confirm the structures of the lignine molecules. Lipoxygenase is a term applied to a group of enzymes which catalyze the oxygenation by molecular oxygen of fatty acids containing a cis-1,4-pentadiene system to produce conjugated hydroxyperoxydiene derivatives. Lipoxygenase activity is widespread in the plant kingdom, often in a very high amounts. Let's see the lipoxygenase inhibitory activity of this molecule. Various concentrations of santolinol is tested against enzyme lipoxygenase, which display inhibitory activity against this enzyme. The IC50 value is shown in the below table. In this activity, the standard drug that is used is bacalene, which shows IC50 value is 22.5, and the IC50 value of santolinol is shown here, that is 20.5, which is very similar and close to that of the standard values. It means santolinol 3, our molecule has strong lipoxygenase inhibitory activity. Dear students, now we discuss the second plant, that is Indigofera hydrantha. The genus Indigofera belongs to family Leguminosae, that is also known as Fabaceae. It comprises of 300 species, all of which are herbs or shrubs, distributed throughout the tropical regions of the globe. In Pakistan, it is represented by 24 species. When we see the pharmaceutical importance of this plant, we observe that it is used as analgesic to relieve ulcer pain. Many other species of this genus are used as anti-inflammatory for insect stings, snake bites, and swelling. Recently, it was found that the phenyl groups on flavonoid skeleton play an important role in anti-HIV. The phytochemical investigations of Inhibitory Hydrantha shows that members of this genus are rich with terpenoids, monoterpenes glycosides, flavonoids, and alkaloids. Phytochemical studies on the whole plant material have resulted in the isolation of 2 new monoterpenes glycosides, and in additions of 4 known compounds have also been isolated from this species. So we will discuss those phytoconstituents which have been isolated and extracted from the genus Inhibitory Hydrantha, and also discuss the elucidations of their structures with the help of proton NMR, C-13-NMR, HMBC, HMQC, and other modern spectral techniques. Let's see the extraction and fractionation of Inhibitory Hydrantha. The whole plant material, that is 25 kg, is grinded and powdered and extracted with methanol and concentrated on rotary evaporator, and we obtain methanolic extract, that is 600 gram. The methanolic extract is partitioned between hexane and water, and we obtain 2 further fractions, and that are aqueous fraction and hexane soluble fraction. The aqueous fraction is further extracted with chloroform and ethyl acetate respectively, and we obtain chloroform soluble fraction and ethyl acetate soluble fraction. The aqueous fractions at the end is further extracted with high polar solvent, that is N-butanol, and we obtain butanol fractions and the aqueous fraction. In this way, we obtain total 5 fractions on the basis of increasing order of polarity of the organic solvents, and these fractions are hexane soluble fraction, chloroform soluble fractions, ethyl acetate soluble fraction, N-butanol fraction, and the aqueous fraction. The ethyl acetate soluble fraction, that is 95 gram, is further subjected to column chromatography by using organic solvent system, that is N-hexane chloroform, chloroform methanol, and methanol. In this way, we obtain total 4 fractions: fraction A, fraction B, fraction C, and fraction D. The fraction A is subjected to column chromatography over silica gel eluting with 9.7 and 0.3% chloroformethanol. We obtain 3 major spots of DLC which confirm the presence of 3 compounds, and that are 21, 18, and 19. Compound 21 is confirmed its purity by using 9.9 and 0.1% chloroformethanol, while compound 18 is confirmed either it has been cured or not by using 9.8 and 0.2% chloroformethanol. The compound 19 is confirmed by its purity by using 9.7 and 0.3% chloroformethanol. Fraction B is subjected to column chromatography over silica gel and eluting with 9.4 and 0.6% chloroformethanol. In this way, after final purification, we get the compound number 20. The purity of this compound is confirmed by using thin layer chromatography in the organic purity system, that is 9.8 and 0.2% chloroformethanol. Fraction C is subjected to column chromatography over silica gel and using increasing order of purity of chloroformethanol, that is 9.5 and 0.5%, and after final purification we get the compound number 16. The purity of this compound was confirmed by using organic purity system order, that is chloroformethanol, in the ratio of 9.8 and 0.2%. Fraction D is subjected to column chromatography over silica gel and eluting with 8.5 and 1.5% chloroformethanol, and after final purification we get the compound number 17. The purity of this compound was confirmed by using 8.6 and 1.4% chloroformethanol organic purity system.